Hello everyone, it's Tutor Mifzal here, and today we are going to discuss about a probability distribution question. But before we do that, do follow me on my Facebook and Instagram account at Tutor Mifzal. And if you haven't subscribed to my YouTube channel, please subscribe to my YouTube channel and hit the notification button to get updated with new videos. So now let's begin with our question today. In a survey, it is found that in a basket of mangosteen, 15% of the mangosteen are rotten. If 8 mangosteen are chosen at random from the basket, calculate the probability that at least 6 mangosteens are. So this over here is a binomial distribution question, and to identify a binomial distribution question and a z-score question, we can see that in a binomial distribution question, we are given the probability of success and the probability of failure. In this case, the probability of failure is the probability or the percentage of rotten mangosteens, whereas the probability of success is the percentage of good mangosteens. Okay, so from this passage over here, or from this question over here, we already know the probability of success and the probability of failure. So the probability of failure, which we will represent with lowercase q, is 15%. But as we all know, we have to change 15% into fraction. So 15% is roughly 15 over 100, and 15 over 100 is equivalent to 0.15. If the probability of rotten mangosteens are 0.15, then the probability of good mangosteens is 1 minus 0.15. In probability, 1 is similar to 100%. Right, so P is equivalent to 0.85. So here are the basic infos that we already know. We have to put our n. Our n is basically the number of the total number of mangosteens in this case. So the total number of mangosteen chosen is 8. So now the question wants us to calculate the probability that at least 6 mangosteens are good. But before we continue with the question, we need to know the formula that we have to use. So the formula that we are going to use is Px equivalent to R is equivalent to NCR times PR times Qn minus R. This is a binomial distribution formula, and you need to memorize this so that it is much more easier for you to input everything inside the formula. So X represents to the number, so R over here represents to what the question really wants. In this case, calculate the probability that at least 6 mangosteens are good. N over here is the number of sample space, or basically the number of mangosteen chosen at random from the basket. In this case, it is 8. And P is the probability of success. In this case, probability of good mangosteens. Q is the probability of rotten mangosteens, or the probability of failure. What we can do right now is that we can apply our information inside this formula over here. But before we do that, we have to identify the R over here. So R is what the question wants. So calculate the probability that at least 6 mangosteens are good. Whenever we say about at least, it means that you must have at least 6 mangosteens are good, meaning that 6 is included inside this number sequence. So here we have 8 mangosteens. If the question requires us to find at least 6 mangosteens are good, then we have to find the probability of getting 6, probability of 7, and also the probability of 8. We are going to write P x is greater than equal to 6. But let's say if the question requires us to find the probability at most 6 mangosteen are good. When we talk about at most, meaning that the number of the probability cannot exceed 6. So 7 and 8 is completely wrong. We have to find the probability of mangosteen that are good from 0 up until 6. So in this case over here, we have to find the probability that at least 6 mangosteen are good. Now if px is greater than 6, then px is equivalent to 6. We have to find the probability of 6 mangosteen are good, and we have to add it up with the probability of getting 7 mangosteen and 8 mangosteen that are good. So with the information over here, we can just substitute all of these values inside our newly formed formula. So px greater than 6 is equivalent to px is equivalent to 6, our n is 8, cs, I'm using this formula over here, multiply by 0.85 times 6, multiply by 0.15, 8 minus 6 is 2. So this one over here is for the probability of 6 mangosteens that are good. Now we are going to find the probability of getting 7 mangosteens that are good. 8c7 times 0.85 to the power of 7 times 0.15, 8 minus 7 is 1. And we have to plus it with 8c8 times 0.85 times 8 times 0.15 to the power of 0. So p x is greater than 6 is equivalent to 0.8948. The probability of getting at least 6 mangosteens are good is 0.8948. So that's about it for today. Thank you so much for watching this video. If you find this video really helpful, do follow me on my Facebook and Instagram account at Tutor Mifzal. And if you haven't subscribed, please subscribe to my YouTube channel. And don't forget to hit the notification button to get updated with new videos. See you soon in the upcoming videos. Bye!